Good day, class. I welcome you to my class today on Greco-Latin square design. Greco-Latin square design is one of the topics that is taught in design and analysis of experiments in statistics. In our previous class, we taught the Latin square design. Last two class, we taught the randomized block design, which is a two-way analysis of variance. We also taught the one-way analysis of variance in this channel. Today we shall be looking at Greco-Latin square design. Once again, my name is Dr. Chris Esekaibe. I welcome you to my YouTube channel, Dr. Chris Esekaibe. The essence of the channel is to share knowledge on key topics in mathematics and statistics across the globe. My area of specialization is numerical analysis, data analysis and modeling, statistical computing, and mathematical computing, and also scientific computing. I hold a doctorate degree in mathematics, I hold a master's degree in mathematics, and a bachelor degree in statistics. You can contact me with any of your research work. If peradventure you are an AI firm, you are looking for mathematicians or statisticians to partner with you, why not? You can contact me. I am open to your consultation. I can work with your team of mathematicians and statisticians. I am a chief lecturer in one of the most prestigious polytechnic in Nigeria. I am also a member of the academic board of that polytechnic. I have scholarly publications at national and international level, and I also have written books in statistics and mathematics, numerical analysis, statistical computing, and the rest of them. My full name is Dr. Chris Esekaibe. My YouTube channel name is also Dr. Chris Esekaibe. My contacts are +23480 330-21903. This first contact is WhatsApp. The second contact is +234-7066-297535. My email address is chrisdavid2015@gmail.com. That is my email address. So we'll be looking at the business of today. The business of today is Greco-Latin square design. Greco-Latin square design. The Greco-Latin square design has a statistical model. The statistical model is Yij Lg is equal to mu. Mu is the overall mean. Yi is the effect of the ith row. Then Cj is the effect of the jth column. Then phi L is the effect of the Lth treatment. The L there stands for the Latin letters. Then our delta G is the effect of the jth treatment, and the G treatment are the Greek letters. Then of course the Eijlg is the error term. Of course, our observation is Yijlg. It means the ith row, the observation in the ith row and in the jth column receiving treatment L and G. So the Greco-Latin square design is an extension. It is an extension of the Latin square design. It is an extension of the Latin square design. It is an extension of the Latin square design. Now, it has an additional source of variation. It has an additional source of variation. It has an additional source of variation that is added to the Latin square design. If you take a look at it, it has 4 sources of variation. These are the 4: the row effect, the column effect, the Latin letters effect, the Greek letters effect. Those are the explained variation as explained by the model. Then the error term is the unexplained variation. So the Greco-Latin square has to do with grouping or classification of units having the same number of levels as treatment, rows, and columns. And these are inserted in the Latin square design to form the Greco-Latin square design. So now the Greco-Latin square design has 4 sources of variation. We have 2 treatments and 2 other sources of variation. That is what it has. It has 2 treatments and 2 other sources of variation. Now, the characteristics of the Greco-Latin square design is not different from that of the Latin square design. It's just that the Greco-Latin square design has 2 treatments and 2 other sources of variation, while the Latin square design has 2 other sources of variation and 1 treatment. So the Latin square design has 3 sources of variation, while the Greco-Latin square design has 4 sources of variation. The major point here is that each Latin letter appears once and only once in each row and each column, while each Greek letter appears once and only once in each row and column. I repeat, each Latin letter and each Greek letter appears once and only once in each row and in each column. So the imposition of each Latin squares form the Greco-Latin square design. So there is an additional source of variation, which is the Greek letters. You can see the row effect, the column effect, the Latin letter effect, and the Greek letter effect. So this is the additional source of variation that makes the Greco-Latin square design to be different from the Latin square design. So it is as explained as that, and it is as easy as that. So the model parameters are RI. The model parameters are the RI, the CJ, the phi L, and the delta G. So these are the model parameters. This one is the row effect, this is the column effect, this is the Latin letter effect, and this is the Greek letter effect. That is what it has. So the sources of variation here, there are 4 in number. So this will now lead us to having 4 sets of hypotheses. So permit me to clean the board so that we can look at the hypotheses that are considered in the Greco-Latin square setting. The set of hypotheses that are considered. We have 4 sets of hypotheses. 1 for the row effect, 1 for the column effect, 1 for the Latin letters effect, and 1 for the Greek letters effect. So the hypothesis for the Greco-Latin square design, Glsd. Now for the row, HO will be, there is no significant difference between the row effects of course, is a pair. The alternative hypothesis will say there is a significant difference between the row effect. That is for the row. Then for the columns, our HO will be there is no significant difference between the column effects. Of course, the alternative hypothesis, this is HO, then the alternative hypothesis will always contradict the null hypothesis. This one will say there is significant difference between the column effects. That is what it does. Then for the Latin letters, then the HO will be there is no significant difference between the Latin letter effects. Then the H1 will be there is significant difference between the Latin letter effects. Then for the Greek letters, the HO will be there is no significant difference between the Greek letters effect. While the alternative hypothesis H1 will be there is significant difference between the Greek letter effects. So these are the four sets of hypotheses that we are going to have when dealing with the Greco-Latin square design. And we make use of the F ratio, we make use of the analysis of variance to carry out this design. They are all under a topic known as, or a course, or a part of statistics known as design and analysis of experiment. We will have the one-way design, which is the one-way ANOVA, which is the single factor. We have the two-way ANOVA, which is the block design. We have the Latin square, which is the three-way design. We have the Greco-Latin square, which is the four-way design. Now, it will interest us to know that it is good we understand the layout of the Greco-Latin square design. I hope you have seen the hypothesis. Now we want to see the layout of the Greco-Latin square design. I want to see the layout of the Greco-Latin square design. The layout of the Greco-Latin square design. So layouts of the Greco-Latin square design is very, very important. Now, you must understand that when you are dealing with, we have two treatments that are involved here. One treatment has the Latin letters, and the second treatment has the Greek letters. Hence the name Greco-Latin square design. The Greek letters, it involves the Greek letters and the Latin letters. Now, let us go ahead and see how we can achieve this. It's a combination of the Greek letters. You have the Latin letters, and we have the Greek letters. note the Greco-Latin square design is a square. So P square is equal to N, the number of observation. So the Latin letters will form a square, the rows will form a square, the columns will form a square, the Greek letters will also form a square. Now for the Latin letters, look at the Latin letter. We are going to have C, B, C, B, A, D. We have B, C, D, A. We have D, A, D, A, B, C, and we have A, D, C, B. These are the Latin letters. For the Greek letters, we have beta, theta, lambda, and alpha. Then we have another set, alpha, lambda, theta, and beta. Then we have lambda, alpha, beta, and theta. Then we have theta, beta, alpha, and lambda. You can see we have now one thing you need to understand about the Greco-Latin square is that our P must be strictly greater than 3. So you cannot do, this one is a 4 by 4, this one is a 4 by 4. So you cannot do the Greco-Latin square when P is 3. P must be strictly greater than 3. So now the Greco-Latin square design will now be, you will say the combination. If you look at this, you have one row, you have each Latin treatment in one row and one column. In one row and one column. So what you need to do, look at C now. C appears only in this row and only in this column. Likewise B. So this is a proper arrangement. That particular condition must be met. Each Latin letter must be in one row and one column. No single Latin letter should be in 2 rows, and no single Latin Greek letter should be in 2 columns. So now what we need to do is to merge them. So we are going to have C. The first one here is C, beta. Then the next one is B, theta. Then the next one is D, lambda. Then the last one is A, alpha. Then this one is B, alpha. This one is C, lambda. This one is A, theta. This one is D, beta. Then this one is A, lambda. This one is D, alpha. This one is B, beta. And this one is C, theta. Then this one is D, theta. This one is A, beta. This one is C, alpha. Then this one is B. This one is B, lambda. So this is the, if you look at this combination, we have been able to combine the Greek and the Latin letters together. And if you look at this combination, you will find out that none of this combination is repeating itself. This is the best practice for the Greco-Latin square design. It is the best practice for the Greco-Latin square design. No particular, look at C beta. You hardly see C beta repeating itself. Look at the Latin letters. Each Latin letter appears once in each row and once in this column. Likewise, each Greek letter, we have 4. So if you are using P to be equal to 3, a 3 by 3 for the Greco-Latin square design, you will end up not having the error term. So the Greco-Latin square design must be above 3. P must be above 3. So from 4 by 4, 5 by 5, 6 by 6, 7 by 7. But the Latin square design can be a 3 by 3 design, 3 by 3 square design. So the Latin square design is greater than 2, strictly greater than 2, while the Greco-Latin square design is strictly greater than 3. So you can see the way we have paired, we have combined them, and you hardly see a combination repeating itself. You will see each combination appear once and only once in each row, and once and only once in each column. So this is how you pick the Greco-Latin square design. You can write out the layout for the 5 by 5 Greco-Latin square design. You can write out the layout for 7 by 7, 8 by 8. All you just need to do, you ensure that each combination appears once and only once in each row, and once and only once in each column. That is what you should have at the back of your mind. So this is a perfect match for the Greco-Latin square design. P must be greater than 3. So you have 4 by 4 square, 5 by 5 square, 7 by 7 square, and so on and so forth. So this is what we have. So permit me to clean this. Then the next thing, we go to the ANOVA layout or format for the Greco-Latin square design. We are going to have the ANOVA format for the Greco-Latin square design. The ANOVA format is very, very important. Now the ANOVA format for ANOVA means analysis of variance. ANOVA format for the Greco-Latin square design is very, very important. As you know, we make use of the F ratio when dealing with analysis of variance. We use the variance to study the equality of means, and the Greco-Latin square design has to do with the consideration of 4 sources of variation, 2 other sources, and 2 treatments are involved. The Latin square design has 2 other sources of variation, while 1 treatment involved, making it 3 sources of variation. Please, once again, my name is Dr. Chris. I'm the owner of this YouTube channel. Subscribe to my channel, click on the notification button, share my videos on your social media platform, like my videos, and as you do, God will bless you. The essence of this channel is to share knowledge on key topics in mathematics and statistics, most especially numerical analysis and statistical analysis and computing. That is my area. I deal in numerical analysis, data analysis and modeling, statistical computing analysis, and scientific computing. So I will be glad to hear from you. My contact, you will see my contact in the description of this channel and at the beginning of each of my videos. God bless you as you do that. Now, as we continue, let us see the ANOVA layout. The first thing is our source of variation, our degrees of freedom, DF. We have our sum of square, we have our mean sum of square, and we have our F ratio. Our F ratio. So these are the headings for the ANOVA. Now the first source there is the row. When you have the row has P minus 1 degrees of freedom. So P minus 1. Then the sum of square for row is SS row. Then the mean sum of square for row is MS row. Then the second one is the column. The column also has P minus 1 degree of freedom. We have the sum of square for the column. We have the mean sum of square for the column. Then the next one is the Latin letters. And it's also P minus 1. So we have the SSL, sum of squares for the Latin letters. And we have the MSL, mean sum of square for the Latin letters. Then the next one is the Greek letters. Then we have the degree of freedom to be equal to the P minus 1. So we have the sum of square for the Greek letters, the mean sum of square for the Greek letters. Then of course, I told you the error term is always there. The error term is now, the degrees of freedom for the error term will now be P minus 3 into P minus 1. So the sum of square is SSE, sum of square for error. Then the mean sum of square for error. Then of course, the last one we have for total. The total is p squared minus 1 for the degrees of freedom. That's what we have for the total. Then the total sum of square is TSS. Then we have that. So you will see that now we have 4 sources of variation. The row effect, the column effect, the Latin letters effect, the Greek letters effect. Of course, the error term is there. Now you can see why P must be greater than 3 for the Graeco lighting square design. Look at the degree of freedom for error. If P is 3, for instance, look at this very clearly. Listen to this vital point. If P is equal to 3, 3 minus 3 will be 0. And also, if P is 3, the sum of square for error will also be 0. It will be, for you to get the mean sum of square for error, it will be 0 over 0, which is undefined. So for the Graeco Latin square design, P must be strictly greater than 3. P must be strictly greater than 3 for the Graeco Latin square to avoid this mathematical error. You now having to divide by 0. 0 dividing 0 is not allowed in mathematics, it's not allowed in statistics. So if P is 3 here, you can see it from the error degree of freedom. It will now be 3 minus 3, which is 0. 0 times this will be 0. And of course, you will not be able, even if you calculate the sum of square for error, you are going to have 0. You are now dividing 0 by 0 to get the mean sum of square for error, which is not allowed. So your P must be greater than 3. So for 4 by 4, P can be 4, P can be 5, P can be 6, at any level of design. Now, the F ratio, we are going to have 4 F ratio because it's 4 sources of variation. The error, because the model explains 4 sources of variation. So now for F ratio for F ratio for arrow, this will be MS arrow all over MSE. Then the F ratio for the column will be MSC, that is mean sum of square for column all over mean sum of square for error. You are dividing each of them by error. Then for the F ratio for the Latin letters, it will be mean sum of square for the Latin letters all over the mean sum of square for error. Then the F ratio for the Greek letters will be equal to mean sum of square for the Greek letters divided by the mean sum of square for error. You see that each of them is being divided by the mean sum of square for error. So that is the ANOVA layout. And it is also important for us to know that the total sum of square, TSS, is equal to the sum of square for the row plus the sum of square for the column plus the sum of square for the Latin letters plus the sum of square for the Greek letters. Now, it will interest you to know that the sum of squares for error can now be placed. So all these are called the explained variation. Okay. The sum of square plus the sum of square for error plus SSE. The sum of square for error is also part of this. Now, if you take a look at these 4 sources of variation, they are called the explained variation. While that of the error, these are called the explained variation. That of the error is called the unexplained variation. So the sum of square for error is the unexplained variation. So these other 4 sources of variation, the row effect, the colon effect, the Latin letters effect, the Greek letter effect, they are all explained variation because they are explained by the model. they are explained by the model. And of course, we can now get the sum of square for error by subtraction. So the sum of square for error will now be total sum of square minus sum of square for row minus sum of square for column minus sum of square for Latin letters minus the sum of square for the Greek letters. So this is the ANOVA format for the Graeco Latin square design. So it is now important we try as much as possible to pick an example and see how far this Graeco Latin square design can be applied. We see how the Graeco Latin square design can be applied. Please wait patiently, watch the video to the end so that you will see the direct application of the Graeco Latin square design. Once again, don't forget to click on the notification button, subscribe to my YouTube channel, Dr. Chris Isekaibe, be part of those sharing knowledge, and as you do, God will bless you. Share the videos, like them, and put them in your WhatsApp platforms and other social media platforms, and God will bless you, your Facebook, and so on and so forth. Now we want to take a practical example and see how we can apply this in a real life situation. Now we call it example. Let's go ahead. 4 block industries. 4 block industries. A, B, C, and D. 4 block industries, A, B, C, and D. Make use of 4 categories of cement. Make use of 4 categories of cement. So they make use of 4 categories of cement from 2 producers, okay? From 2 producers, Ayub and Tunes. Ayub and Tunes, they are the 2 producers of the 4 categories of cement. The cement were combined, that means they were mixed in modeling. The cement were mixed in molding 6-inch blocks. We'll combine the molding 6 inches block at 4 different weather conditions. At 4 different weather conditions. At 4 different weather conditions. The sample are sent to the data. The data are seen below. Now let's see the data and the question. Let's write the data before we write the question. So the data, we are going to have weather condition. We have the weather condition. We have the block industries. The block industries are A, B, okay, A. The block industries are A, B, C, and D. The block industries are 4. Then, of course, the weather condition, we're also told that the weather condition is 4, so you name it 1, 2, 3, and 4. So these are the 4 weather condition that we have. Now we are going to bring out the first one under A is C beta, and that is 10. Then under B is B theta, and that is also 10. Then under C is D lambda, and D lambda is 7. And under block industry D, we have A alpha, and that is 10. Then for the second weather condition, we have B alpha, and that is 8. The next one is C lambda, and that is 12. And the next one is A theta, and that is also 12. And the last one is D beta, and that is 9. Then under weather condition 3, we have A lambda, and that is 11. We have D alpha, and D alpha, that is 9. Then the next one, we have B beta, and that is 10. And the last one there is C theta, and that is 8. Then for the fourth weather condition, we have our D theta, and that is 13. Then we have our A beta, that is 8. And the next one we have our C alpha, that is 14. C alpha is 14, and the last one is B lambda, and B lambda is 15. Now, it will interest you to know that you can see the Latin letters and the Greek letters by the side of it, having their various measures. Now, the next thing is to ensure we have our totals. We should have our totals. Let's have the totals. Then let's also create a column for the totals. So we are going to have it this way. It's a simple thing to do. The first thing you do, sum the row and sum the column, so that you can have the row total, the column total, and at the end of the day having what we call the grand total. The sum for this one, if you want to rule here, you are permitted to rule it this way. You can also have this one here like this, have it like this for easy differentiation. Now this will be 42. You add this, 10 plus 8 plus 11 plus 13. Then the next one is 39. Then the next one is 43. Then the next one is 42. Then again, you go to the total. These are the column totals. The total for the row, you add all these, this will be 37. The next one will be 41. This will be 38. And the last one, you add it up, that will be 50. Then you add the grand total, will be the grand total will be 166. 166. That will be the grand total. So that is the first thing you do. Here you have to carry out the analysis. This design, the question says identify the design and analyze at 5% or at alpha is equals to 5% level of significance. That is the question. Now you have to identify the question. So the grand total here is 166. So we have to write it well, 166. That is the grand total here. So now, is this design a Latin square design? Is it a Greco Latin square design? Now let us check. Look at the Latin letters. The A, B, C, D is a 4x4 Latin, Greco Latin square design. Look at the Latin letters appearing once in each row and column. The Greek letters are beta, theta, lambda, and alpha. And you will see theta appearing once and only once in each column. Look at this one. This is beta, this is alpha, this is lambda, this is theta. Only once it appears. Look at beta, look at theta, look at lambda, look at alpha. Only once it appears. Look at A, look at B, look at C, look at D. Only once it appears. And so you check it row by row and column by column, and you find out that the design is a Greco-Latin square design. So the design is a Greco-Latin square design. So because, why is it a Greco-Latin square design? Each Latin letter, the Latin letters are A, B, C, D. The Greek letters are beta, alpha, lambda, and theta. They appear once and only once in each row and each column. So that is the beauty of the Greco-Latin square design. Now, permit me to clear this part of the question because we are going to go into computation. We are going to go into some computation. Now, the first step is to set the null and alternative hypothesis. You must understand what do you have in the rules. These are block industries. What do you have in the rules? The rules are the weather conditions. 1, 2, 3, 4. What do you have in the columns? The column is the block industry. We have the block industries represented in the column. The block industries are represented in the column. So it is important you know that you must be able to differentiate between the block industries and the weather conditions, and also the Latin square, the Latin letters, and the Greek letters. You should be able to differentiate. The Latin letters are A, B, C, D, while the Greek letters are there are beta, alpha, lambda. So you have those. So when you are calculating the sum of squares, you should be able to differentiate the Latin letters from the Greek letters. If you are able to do that successfully, then you can calculate the sum of squares for the Latin letters and the sum of squares for the Greek letters. It is as important as that. So you should be able to differentiate. You should know that the weather conditions are the rows, while the block industries are the columns, and of course the A, B, C, D are the Latin letters. The beta, the alpha, the lambda, and the theta are now the Greek letters. So that is what you are going to do. So now the step 1 is to state our hypothesis. We are taking it step by step. Step 1. state HO and H1 clearly. That is the first thing you are going to do. I stated this during the explanation. Now we have 4 sources of variation. So you are going to have 4 sets of hypotheses. So for the rows, we have 1, 2, 3, 4, which are the weather conditions. So HO will be, there is no significant difference between the weather condition. Then the H1 alternative hypothesis will be, there is significant difference between the weather condition. Then for the columns are the block industries. We have 4 of them, A, B, C, D. So the hypothesis will be, there is no significant difference between the block industries, A, B, C, D. Then the H1, the alternative hypothesis will be, there is significant difference between the 4 block industries. Then the third hypothesis is for the Latin letters. The Latin letters are the products from the IUP company. So now step 2, compute the sum of squares. So you must differentiate something. Note that A, B, C, D are products, or you can call them cement products from IU, and they are the Latin letters. Then our alpha, beta, theta, lambda are cement products from tools. Remember, we have 2 cement industries, and these are our Greek letters. So you must take note of that. You must be able to distinguish between them. So these are the 4 cement products from IU Cement Company. Then the alpha, beta, theta, and lambda are the cement products from the Tones cement factory, and they are now representing the Greek letters. So you can see here that we have 2 treatments, that means the Greek letters and the Latin letters, and we have 2 other sources of variation. The other 2 are the block industries and the weather conditions. So this is a perfect 4x4 Graeco Latin square design. So now we move to calculating the correction factor. So the first one here is A. We want to calculate the correction. So the correction factor is CF is equal to summation y squared dot because they are 4 all over p squared, and this will be 166 squared all over 16. So our correction factor, so when you 166 squared all over 16 will be 177, will be 1722.25. That is our correction factor. So the correction factor helps us to do that. Now we have calculated the correction factor to be 1722.25. Then the B, now I'm making to clean this part. Note we have seen that the design is a Graeco. We have been able to establish that fact that the design is a Graeco Latin square design. Then the B is to calculate our total sum of square. and that is given by summation y square dot minus the correction factor. That means you are taking each of the y, of course it runs across the first summation, 1, 2, 3, 4, then y square dot, or it can come like that, I, J, L, and G. So from the ith, each observation in the ith row to the jth column, receiving the lth treatment and the gth treatment. That is the Latin letter treatment and the Greek letter treatment. So our TSS will run across this. We have 16 observations here. So we are going to square each of them. So this will be 10 square plus, the next one is 8 square plus, the next one is 11 square plus, the next one is 13 square. Permit me to continue from here. Then plus 10 square plus 12 square plus 9 square plus 8 square plus 7 square plus 12 square plus 10 square plus 14 square plus 10 square plus 9 square plus 8 square plus 15 square. You cover it, then minus our correction factor is 1722.25. So now let's count the observations. They are 16 because it's a 4x4 Graeco Latin square design. Now look at, let's count it here to ensure that no one is omitted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's correct. So it simply means that if it is a 5 by 5 Graeco Latin square design, then it will be 25 in number. If it is a 6 by 6, it will be 6 square, which is 36 in number. If it is a 7 by 7, it will be 7 square, which is 49 in number. So our total sum of square, our TSS. So when you carry out this arithmetic, you square each of these 16 items and add them together. You are going to get a total of 1802 minus the correction factor 1722.25. And then when you carry out that simple arithmetic, our TSS, which is the total sum of square, will be 79.75. 79.75. That is our total sum of squares. So I believe that has been taken. So then the C, we have done 2. Then permit me to clean this step so that we can make progress with what we are doing. So now we want to calculate the sum of square for the rows so that we can begin to make progress. Please take note of these values. You can take note of it. It's very, very important. So now the next one is to calculate the SSR, that is the sum of square for row. So our SS row will be equal to summation. You know the row is I, so it will be y square I dot all over P minus the correction factor. So this will now be equal to, now we are not taking the row totals. The row totals. Now you're talking about the weather condition. The rows are the 4 weather conditions. So you are taking their totals. So the first total here is 37. The second one is 41. The next one is 38. The last one is 50. So you open a bracket. You have 37 square all over. Each of them is 4. 1, 2, 3, 4. P is 4. Plus the next one is 41 square all over 4. Plus 38 square all over 4. Plus the last one is 50 square all over 4. You close the bracelet. then minus the correction factor minus 1722.25. So if you now come here, our sum of square for rho, sum of square for the weather condition will be, when you carry out this simple arithmetic, you are going to have 1748.5. 1748.5 minus correction factor 1722.25. Then at the end of the day, the sum of square for rho is going to be 26.25. 26.25. That's our SS rho. So permit me to get our SS column. I will have to claim the correction factor, and this is part of the total sum of squares. So permit me to write it under this part. So the next one is our SS colon is equal to summation. The colon is J, so dot J dot square all over P minus the correction factor. So if you are dealing with the colon is J, if you are dealing with the row is I, if you are dealing with the Latin letters is L, if you are dealing with the Greek letter is G. So permit me to also clean this part so that we can have enough space to write what we are writing. So that we can have enough space to write. So click on the share button, share this video, like the video, wait patiently to watch it to the end, and at the end of the day, you will be glad you did. So the sum of squares for the columns are the block industries, the 4 block industries. So we are dealing with the column total. The column total are 42, 39, 43, and 42. So you are going to have SSC is equal to, you open a bracket, 42 square over 4 plus 39 square all over 4 plus 43 square all over 4 plus 42 square all over 4. Then you cover the bracelet minus the correction factor is 1722.25. So our XX colon, which is the sum of square for column, which is the sum of square for the block industries. These are the columns: 42 square over 4 plus 39 square over 4 plus 43 square over 4 plus 42 square over 4. Then when you carry out that arithmetic, you're going to get 1724.5. 1724.5 minus 1722.25. So our SS column, which is the sum of square for the column, sum of square for the block industries, when you subtract 1724.5 from 1722.25, you have 2.25. 2.25. That is what you are going to have. Now, the next thing is to calculate our sum of squares for the Latin letters. The sum of squares for the Latin letters. The sum of square for the Latin letters is simple. So we'll come here. So this is the SS Latin letters. That would be the E. So this one is D. This one is C. Sum of square for row is C. Sum of square for column is D. Then the sum of square for the Latin letters is E. So our SSL is equal to summation Y dot L dot, because this thing is, the Latin letter is L, then all over P minus the correction factor. Now, before you do this, you are going to bring out the Latin letters and have their squares. If you don't bring them out and have their squares, you will not have the best result. So now let's bring them out one after the other. If I'm bringing out A here is 10. Look at it here. A here is 10. A here is 12 plus 12. Then the third row, A here is 11. Plus the fourth one, A here is 8. Then you get the total. Then you bring out your B. Here, B here is 10. plus B here is 8, then B here is 10, you take it row by row, then B here is 15, then the next one is C here is 10, then the second row C here is 12, then the third row C here is 8, you have 4, then for the fourth row C is 14, plus 14 you have that, then you take your D, for the first row D is 7, then the second row D is 9, then the third row D is also 9, D is also 9, then for the fourth row D is 13. So now let's add them up. If you say 10 plus 12, 10 plus 12 plus 11 plus 8, you have 41 here. Then the next one, 10 plus 8 plus 10 plus 15, you have 43 here. Then the third one, 10 plus 12 plus 8 plus 14, you have 44 here. Then the last one, 7 plus 9 plus 9 plus 13, you have 38 here. So you can now go ahead to calculate the sum of squares for the Latin letters. The sum of squares for the Latin letters. Sum of squares for the Latin letters. You now come and calculate the sum of squares for the Latin letters. Permit me to write this very well. Graeco Latin square. Graeco Latin square design. So that is the topic. So now we are looking at the sum of squares for the Latin letters. So our SSL will now be equal to, this is the formula. So we are going to take each of these. So you have 41 square over 4. Take 41 for A, then plus 43 square over 4. The next one is 44 plus 44 square over 4. Plus the fourth one is 38 plus 38 square over 4. Then minus the correction factor 1, 722.25. So our sum of square for the Latin letters, if you carry out this arithmetic, you are going to have 1727.5. 1727.5 minus 1722.25, and that will now give you the sum of squares for the Latin letters SSL will be 5.25. That is what you are going to have. You are going to have 5.25. It is as simple as that. So you can see that we are making progress in this. So the sum of square for the Latin letters is 1727.5 minus 1722.25, and that is 5.25. So permit me to go ahead to get the F1, which is the sum of square for the Greek letters. So we are going to get the sum of squares for the Greek letters, SSG. The sum of squares for the Greek letters. Permit me to go ahead and do that, and that will be number F. That will be F in our, so our F will be SSG, and that is equal to summation Y dot G square all over P minus the correction factor. Now we are going to write out the Greek letters so that we can get their sum of squares. Now let us start with the first one, alpha. Here, what is alpha? Alpha is 10 plus here, what is alpha? The second row, alpha is 8 plus here, what is alpha? Alpha is 9 plus the last one, what is alpha? Alpha is 14. Then the next one, let's go for beta. For the first row, what is beta? The value for beta is 10. Then the second row, what is beta? Beta is different from B, please. Don't mistake beta for B. then here beta is 9, then the third row beta is 10, then the fourth row beta is 8. Then now we are looking at theta. For the first row theta is 10, the second row theta is 12, then the third row theta is 8, then the fourth row theta is 13, then the last one is lambda. Lambda, for the first row lambda is 7, then the second row lambda is 12, then the third row lambda is 11, then the fourth row lambda is 15. So we are going to sum them up. So we are going to have 10 plus 8 plus 9 plus 14, that will give you 41. Then the next one is 10 plus 9 plus 10 plus 8, that will give you 37. Then the third one for theta is 10 plus 12 plus 8 plus 13, that will give you 43. Then the last one for lambda is 7 plus 12 plus 11 plus 15, that will give you 45. Now let us go ahead and calculate this. So our SSG will be equal to, what's the first value here? 41 squared all over 4, plus the next one is 37 squared all over 4. Then the next one is plus 43 squared all over 4. Plus the fourth one is 45 squared all over 4. We put it in bracket minus the correction factor 1722.25. So our SSG, sum of squares for the Greek letters, when you carry out that arithmetic, you square and divide and take the sum, you have 1731 minus 1722.25. So our sum of square for the Greek letters SSG will now be equal to 8.75. 8.75. That is what you have. Sum of squares for the Greek letters is 8.75, and that is our F. Then our G, that's our F. Then our G is to get the sum of square for error. I told you from the beginning, in all analysis of variance, it's preferable to get error by means of subtraction. The total sum of square has all, permit me to clean this part, is the sum of all the four variations, the sum of the four source variation, their sum of square is the explained variation, while the sum of square for the error is the unexplained variation. So our G, our F, our G, we now want to calculate the sum of square for error, and that will be equal to the total sum of square minus the sum of square for rows, minus the sum of square for column, minus the sum of square for the Latin letters, minus the sum of square for the Greek letters. So now we are going to get that cheaply. Our SS error, we have our total sum of square from calculation is 79.75. 79.75 minus the sum of square for the row is 26.25 minus the sum of square for column. The sum of square for column is 2.25 minus the sum of square for the Latin letters is 5.25. Look at it here, minus 5.25. Then the sum of square for the Greek letters is minus 8.75. And when you carry out that simple arithmetic, you are going to get 37. You are going to get 37.25 for the sum of squares for the error. So we have concluded step 2. We have been able to get all the sum of squares. So the next step now is step 3. We have to construct the Graeco Latin square ANOVA table. Our next step, permit me, I hope you have seen all the sum of squares, how they were calculated. Now I want to clean the board completely so that we can calculate or we can construct our ANOVA table, which is step 3. Then we go to step 4 to get our table values. Then from there we get we decide and we make our conclusion. We decide and make our conclusion. That is what we are going to do. So it is very interesting that you are part of this class. Share the video and ensure that you are part of those sharing knowledge across the globe. As you do, God will bless you and increase you. So now let us look at step 3. We have looked at step 1. Step 1 talks about stating the hypothesis, the null and alternative hypothesis for the 4 sources of variation, sum of squares for the block, the weather condition, sum of square for the block industries, sum of square for the Latin letters, sum of square for the Greek letters. Now our step 3, construct the ANOVA table for the Graeco Latin square design. So it is as simple as that. So we have our source of variation, we have our degrees of freedom, we have our sum of square, we have our mean sum of square, and we have our F ratio. So permit me to roll this out so that we can take them step by step. Now, our first source of variation, we are taking them one after the other. Our first source of variation is the row, and the rows talk about the weather condition. So we have the row. When you talk about the rows are the weather condition, and we abbreviate it so that it will be easier to understand. So we have our row. So it's our weather condition. Let me put it in brackets. So the degrees of freedom for row is P minus 1. So this is 3 minus 1, and that is equal. No, sorry. Our P is 4. Okay, it's P minus 1. That is P minus 1 is equal to 4 minus 1 is equal to 3. So our SS row that was calculated is equal to 26.25. Then we keep it at this. Then the number 2 is the colon. We can use this line to differentiate. Number 2 is the colon. And the colon talks about the block industries. Let me call it BI. The block industries. And the degrees of freedom is also P minus 1 is equal to 4 minus 1, and that is equal to 3. Then the SS colon, sum of square for the colon, and that is equal to 2.25. So permit me to roll this line. Then the next one is for the Latin letters. The Latin letters. And these are IU cement products. The IU cement products for the Latin letters. So the degrees of freedom also is P minus 1, and this goes to 4 minus 1, and that is equal to 3 for the IU cement products. Then the SSL, sum of square for the Latin letters. Sum of square for the Latin letter is 5.25. Then we go again. The Greek letters, and the Greek letters are the Tons cement products. The Tons cement products. Then, and of course, our degrees of freedom for that is also P minus 1 is equal to 4 minus 1 is equal to 3. Then our sum of square for the Greek letter SSG, sum of square for the Greek letter is 8.75. 5, that is what we have. Then we roll that again. Then of course we come again. We have for the error. The error has degree of freedom to be p minus 3 into p minus 1. Now p minus 3 will be 4 minus 3, 4 minus 3 into 4 minus 1, and that will be, okay, let me just write it together. 4 minus 3, 4 minus 3 is 1, 4 minus 1 is 3, 3 times 1 is equal to 3, let me put it there straight away. So we are calculating, then our SS error is equal to 37.25, 37.25. Then you roll it down, then we have our total degrees of freedom. Permit me to do it here like this. Our total degree of freedom is p squared minus 1, and that is 16 minus 1 is equals to 15. So it's equal to, this is p squared minus 1, 16 minus 1 is equal to 15. So 16 minus 1 is 15. So our total sum of square is 79.25. So TSS is equal to 79.25. 0.75 rather. So it's 79.75. That's our total sum of square is 79.75. So total will be p squared minus 1, that is 16 minus 1, that is 15. So if you now come here, you add 3 plus 3 plus 3 plus 3 plus 3 is 15. 3 and 5 places 1, 2, 3, 4, 5 is 15. So the sum must definitely tally. So now let's go to the mean sum of squares so that we can have better understanding of what we want to achieve. So for the first one, we have it like that. So now for the row, to get mean sum of square, you divide the corresponding sum of squares by their corresponding degrees of freedom. So this will be 26.25 divided by 3. This is the sum of square for the row. Then when you divide it by 3, you are going to have 26.25 divided by 3, you have 8.75. Then this one will be 2.25 all over 3 divided by 3, and that will be 0.75. Then the next one will be 5.25 over 3. When you divide 5.25 over 3, you are going to have 1.75. And of course, the last one is 8.75 over 3, and you are going to have 8.75 divided by 3, you are going to have 2.92. 2.92. That's what you are going to have. Then 37.25 divided by 3. 7.25 over 3. That will be 12.92. You are going to have 12.42. You are going to have 12.42. So that is what you are going to have. So now we are going to have F ratio for the form. How do we get the F ratio? We are going to divide by the corresponding degrees of freedom. We are going to divide, by the main sum of squares for error. So for this one, to get the F ratio for the weather condition, we can call it FF. We can call it F arrow, and that will be equal to 8.75 all over the degrees of freedom, the mean sum of square for error all over 12.42, and that will be equal to, you divide that, you are going to get 0.70. Then for the next one, F colon will be equal to 0.75 all over 12.42. You are going to get 0.06. Then our F Latin letters will be 1.75 all over 12.42. So our F Latin letters will be equal to 0.14. Then our F Greek letters will be equal to 2.92 all over 12.42. So FG Greek letters will now be equal to 0.235. So you can see here now that we have 4 F ratios. One for the rows, that is the weather condition. One for the column, that is the block industries. One for the Latin letters, that is the IO cement products. And one for the Greek letters, that is the Toons cement products. That is what we have there. Now we want to take our step 4. Get the table value. So now how do we get our table value F? Now you are also going to get 4 table values because you have 4 sources of variation. Each against we use the degrees of freedom to get the table values and at a particular alpha, that is the level of significance given. Note our alpha that is given, our alpha is 0.05, that is 5%. So now we are checking this 3 against that the degree of freedom for the row against the degree of freedom for error, that is 3 against 3. The degree of freedom for column against the degree of freedom for error, that is 3 against 3. The degree of freedom for the Latin letters against the degree of freedom for error, that is 3 against 3. The degree of freedom for the Greek letters against the degree of freedom for the error, so it's 3 against 3. You are going to have a single value. So you are going to have 0.05. So you go to the 5% table for the F distribution table, that is the Fisher's distribution table, the F table at 5%. You check 3 under 3. You see the V1 are the columns, the V2 and the rows. You just check 3 under 3. When you check that, you are going to get our table value to be 9.28. So you are going to get 9.28. That's our table value. Note our estimated sigma square, that's estimated population variance, is 12.42. The mean sum of square for error. The mean sum of square for error is always the estimated population variance. The population variance is sigma square. This is how we write it in statistics. Sigma square. So the estimated sigma square, which is the estimated population variance, is the mean sum of square for error. Not the sum of square, the mean sum of square for error, which is 12.42. That is our estimated population variance. So every ANOVA table has an estimated population variance, because what does the ANOVA table do? The ANOVA table uses variance. to test for equality between means. So it is ANOVA, and that's where the name comes from, analysis of variance, in short form ANOVA. So it uses variance to test for means, for differences among means, for significant differences among means, among various groups. I hope you are getting that. Now the last step is step 5. We have to decide and conclude. Our step 5, we have to decide and conclude. Step 5, decide and conclude. Now we are taking them one after the other. Now, for the weather condition, look at it here now. What is F-cal? Our F-cal is, the calculated value is 0.70, is less than F-tab of, our F-tab is 9.28. 9.28. So if calculated value is less than, what do? We accept HO. HO now, that means no significant difference. That means no significant difference among the weather conditions. No significant difference among the weather conditions. That is what it has told us. Then for the next one, for the column, is the block industries. So for the block industries, we are also going to make a decision. Our F-cal, what is our F-cal for the block industry? The block industries are the columns is 0.06. 0.06. Of course, it's still less than F-tab. Our F-tab remains 9.28. So at this point, we are also going to accept HO. It means there is no significant difference among the block industries. There is no significant difference among the block industries. No significant difference among the block industries. That is for us. Then, now for the Latin letters, that is the Latin letters. The Latin letters are the IOP cement products. The IOP cement products for the Latin letters, they are IOP cement products. So what is our calculated? We have our F-cal of 0.14 is less than F-tab of 9.28. So if calculated is less than table, you accept HO again. That means no significant difference between the IOP cement products, which are the Latin letters. Then for the Greek letters, this one is the Tombs cement products. That's what we use to represent the Greek letters. So now our F-cal of 0.235 is less than F-tab of 9.28. So what do we do in this case? We are going to accept HO. We are going to accept HO and conclude that there is no significant difference among the Greek letters, among the Toons cement products. The Toons cement products are 4. They are the Greek letters. The Latin cement, the IUP cement products are 4. They are the Latin letters. So you can see that at each point of the analysis, the null hypothesis is accepted at the 4 various levels. So the Greco-Latin square design is a 4-in-1 test. It's a 4-in-1 test. You can see the 4 decisions. The table value, which is 9.28, is strictly greater than all the F ratios. The F ratios from the 4 different sources of variation. So you can see below that we have been able to carry out this analysis from the beginning to the end. It's a bit cumbersome, it's a bit tedious, it's time consuming, but the joy of it is that it is worth it. I hope you have learned something patiently from the beginning to the end. Please, once again, my name is Dr. Chris Esekaibe. Subscribe to my YouTube channel, Dr. Chris Esekaibe. Share my videos in all social media platforms, and like my videos. Be part of those sharing knowledge across the globe. The essence of this YouTube channel is to share knowledge on key topics in mathematics and statistics, preferably numerical analysis, data analysis, or statistical analysis and computing. God bless you for watching today's video. I'll be coming up with another topic in our next video. We have been able to look at designs and analysis of experiment. We looked at 4 different designs: the one-way analysis of variance, which is the completely randomized design; the two-way analysis of variance, which is the completely randomized log design; the Latin square design, which is also a 3-way, which involves 3 sources of variation. And today we looked at the Greco Latin square design, which is also the 4-way, which takes care of the 4 sources of variation, 2 treatments, and 2 other sources of variation. The difference between the Latin square design and the Greco-Latin square design is that the Greco-Latin square design has an additional source of variation called the treatment, making the treatment to be 2. God bless you. Keep watching my videos, keep sharing my videos, keep subscribing, and I will be looking forward to hearing from you. If you have a topic that you want me to teach on, put it on the comment section. My contacts are in my description part of the video. My contacts are there. You can send me a message, send me a WhatsApp message, or make a call, or send me a message via my email. I will be glad to attend to your needs. If you are an artificial intelligence firm or a research institute across the globe, I work in Nigeria, I live in Nigeria, I teach mathematics and statistics. I'm an expert in numerical analysis, data analysis and modeling, statistical analysis, and scientific computing. You can consult me with your research work, or you want me to be part of your team of researchers. Why not? I will be glad to be part of increasing knowledge or sharing knowledge. God bless you. Enjoy the rest of the day. Bye.